Hi everyone, welcome to my YouTube channel. I hope you all are fine. Today I brought you this question from JEE-ADVANCED 2020 question paper where m equals to minimum of log base 3 raised to power y1 plus 3 raised to power y2 plus 3 raised to power y3 where y1, y2 and y3 are real numbers. Sum of y1 plus y2 plus y3 is given as 9. Capital M equals to the maximum of log base 3 x1 plus log base 3 x2 plus log base 3 x3 where x1, x2 and x3 are positive real numbers and sum of x1, x2 and x3 is given as 9. We have to find the value of log base 2 m cube plus log base 3 m square. This problem will test your knowledge about the logarithmic properties and the relation between the means of some data. Okay, and here we need to find this value, and for solving complete this we need to find first small m and capital M. After that we'll put these values in this formula and solve for the answer. Okay, so before we start the solution, let me give you a brief idea about how many means we have and what is the relation between these means. Okay, so here we have four kinds of means. RMS mean will be root square mean, AM for arithmetic mean, GM for geometric mean and HM for harmonic mean. These means collectively used as RMS, AM, GM, HM inequality. This relation can be useful in mathematics computation and for solving proofs. Separately, these four values can be solved or computed by these four formulas. RMS will be given by root of a square plus b square by 2. Arithmetic mean will be given by a plus b by 2, geometric mean will be given by root of a into b, and harmonic mean will be given by 2 oblique 1 upon a plus 1 upon b. The relation between these four means is RMS will be greater than equals to arithmetic mean, will be greater than equals to geometric mean, will be greater than equals to harmonic mean. For this equality sign, the condition should satisfy that a equals to b. Let's solve the problem now. For solving this problem, we will use this part of the property of mean, that is arithmetic mean is greater than equals to geometric mean. Okay, let's write the data from the question, that is first this log base 3 raised to power y1 plus 3 raised to power y2 plus 3 raised to power y3. Here I should write as 3 raised to power y1 plus 3 raised to power y2 plus 3 raised to power y3. We have three value here, so arithmetic mean of the three value will be like upon 3. This will be the arithmetic mean, and geometric mean for this data will be root of, here 3 will be, because there are 1, 2, 3 points, so it will be 3, and 3 raised to power y1 into 3 raised to power y2 into 3 raised to power y3. So I have written in the form of this is the arithmetic mean, which is greater than equals to the geometric mean of the same value. Okay, we can write this geometric mean value as root 3 as in the form of power, so 3 raised to power y1 into 3 raised to power y2 into 3 raised to power y3 whole raised to power 1 by 3. Okay, we can represent this value as this. Okay, same, the both are same, so let's just multiply this. As you can see, the base of all threes are same and they are in multiplication. So the rule says when we have same base, the power adds. Okay, so y1 plus y2 plus y3 and this is 1 by 3. Okay, and we know the value of y1 plus y2 plus y3 from the question. It says y1 plus y2 plus y3 equals to 9. So we'll put here 3 raised to power 9 raised to power 1 by 3. So it will be 3 raised to power 3. Okay, I hope you know how to solve this. If there is power to the power, then we just multiply the values. Okay, now we have this, so bring the denominator part of the other side to this side. so that these three values separate from all other restrictions. Okay, so I should write this value below for further going on. 3 raised power y1 plus 3 raised power y2 plus 3 raised power y3, and I brought the denominator value to other side, that is 3, so I can write it now as 3 raised power 4. Okay, and here it is 3 raised power y1 plus 3 raised power y2 plus 3 raised power y3. And now, as in the question, we are given with log of this 3 value, so we have to apply log on both sides to get the desired value. Okay, so applying log base 3 on both sides, so log base 3, 3y1 plus 3y2 plus 3y3 will be greater than equals to 3, here I should log base 3 raised power 4. Okay, and now we know the property of log, where if we have log base a of a and to the power b, then the answer will come as b into log of a, where this results in 1, so we will get b only. Okay, so here we will get 4 only. Okay, now you know that this value, it was equals to this, and we have to find m, which is minimum of this value. Okay, so we find that this value is greater than equals to 4, so for this data the minimum value will be equals to 4. Okay, so that this value will be minimum, so 4 will be minimum, so our answer m will be equals to 4. Okay, now we will go for m, capital M, which is given by this. So let's write this data. Okay, log base 3 x1, log base 3 x1 plus log base 3 x2 plus log base 3 x3, and we will use the same condition, arithmetic mean greater than equals to geometric mean. Okay, and now this 3 values, log x1 plus log x2 plus log x3, are in the addition form. Okay, and by the log property you should know that log of a plus log of b plus log of c equals to log of a into b into c. We can write this as like this. So let's write our value here, log base 3 x1 into x2 into x3. Okay, so now let's use this internal data for further calculation. For arithmetic mean we have x1 plus x2 plus x3 upon 3. This is the arithmetic mean and should be greater than geometric mean, that is 3, x1 into x2 into x3. We can write this data as x1 into x2 into x3 raised to power 1 by 3. Okay, and we are given with this value x1 plus x2 plus x3 in the question, that is x1 plus x2 plus x3 equals to 9. So we will use here 9 oblique 3. Okay, so it will become 3 greater than equals to x1 into x2 into x3 raised to power 1 oblique 3. Now we can bring this power to other side in other form, 3 raised to power 3 to x1 into x2 into x3. Okay, now we want the log of this value, so put log both side. So putting log base 3 on both side, so log base 3 raised to power 3 will be greater than equals to log 3 x1 dot x2 dot x3. So this will be 3 log base 3 3. will be greater than equals to log 3 x1 x2 x3. Okay, and as per log property, this value come as 1, so we will write it as 3 greater than equals to log base 3 x1 x2 x3. So now what this expression represents? This expression represents that whatever the value we put for x1 x2 and x3, the whole value cannot be greater than 3. So indirectly we can say that 3 is the maximum value for this data. Okay, and so I can write it as maximum of log 3 x1 x2 x3 equals to 3. Okay, and which is equals to capital M. Okay, we got our second demand or requirement, that is capital M, which is equals to 3. So now we have found both the values, small m and capital M. That was our previous required data for solving this equation. So let's write this equation, put these values and get our answer. Okay, log base 2 m cube plus log base 3 m square. Log base 2 m cube plus log base 3 m square. We found small m as 4 and capital M as 3. So here I should write log base 2 4 cube plus log 3 square base 3. I can write this 4 as 2 raised to power 2 to make the base and value same. So log 2 2 and 2 3. Okay, plus log 3 3 square. As the log property, the power will come in front of the log, the same with this. So 2 into 3 log base 2 and 2 plus log 3 3, here it will come 2, and this data will come 1, this data will become 1. So our answer will be here 2 into 3, that is 6 and plus here 2. So our answer will be 8 for the problem. Okay, so we found the solution. I hope you understand well. If you find any difficulty in solving this problem or have any doubt, please feel free to ask in the comment box. Thank you and have a good day.